I will start with a bit of background because the game industry is a bit different than others. And so what I'm doing is I'm really accepted. So why first? There's many reasons. The first one is curiosity. It's one that people, so it's not anything evil, it's just wanting to know how the, yeah. Oh, sorry. Test. Okay. Sorry. So yeah, curiosity is the first and main driving force to reverse engineer a game server or game, any game. And you can have research which is tight, but it's more for people who like filling out wikis with information about the game. There's a lot of these. And of course, you can use all this information to build your own server. And why would you do this? Maybe you can't pay for the game, but that's usually not a good motive. Usually it's because the game is going to be shut down. And that means you can't play this game anymore. And that sucks. So, like I said, it's a bit different in the gaming industry. Curiosity isn't really rewarded. So, even data mining is considered cheating. I actually got a few people from the company doing the game I will talk about say this: data mining is cheating. You can't look at the files. They're on your computer, but you can't look at them. They don't expect you to. And they do everything they can to protect files. And of course, reverse engineering is also cheating, looking at the protocol, the client, everything else. They want it to be a complete black box, and you just play on it. But of course, there are people like us who like going into things. And even if you don't make use of that knowledge, they will still think you are a cheater and should be banned and everything. And you can't convince them. You can't even convince them that they shouldn't have to hide everything, because people will find them anyway. So to protect their games, there's a few anti-cheating technology. There's Valve has whatever it's called, sorry. And this game has Game Guard, which is actually very awful. It's considered by many security companies like a virus, because it opens the flow in Windows, and when you uninstall it, it doesn't fix it. It stays there. It's pretty bad. And this doesn't actually do anything. You can always bypass it. It's very easy. Game Guard, for example, and today still, you can simply run your debugger or memory viewer in 64 bytes mode, and Game Guard will not detect it because it only works with 32 bits mode. And that's pretty useless. Why is it there? It only slows down the game because it keeps scanning the memory and preventing nothing. So yeah, it's easy. And another barrier of entry, mostly for people like us, is that most games are on Windows, so you need a Windows install for most of them, mostly because things like Game Guard don't run on Linux or Mac OS. And so there's no other choice than to install Windows. So it's a bit philosophical, but you have to take that step. And of course, if you do actual gaming, not just a little, you probably have that Windows box at home. So the game I'm talking about is Fantasy Star Universe. It's a game by Sega. which was created in 2006 and follows the Phantasy Star Online game. Is there anyone knowing Phantasy Star Online or Universe here? No? Yeah, 1%, 2%, okay. Phantasy Star Online was the first console MMORPG. Well, not really MMORPG, there wasn't that many people at the time, but it was the first online RPG on console. It was on GameCube initially, and then went on to Xbox, PC, and I'm sure I'm forgetting one, Dreamcast, yeah. And then that game was released in 2000, I think, and very quickly, even though it was on console, there was a lot of cheaters on the game. Because simply, that company doesn't know how to protect the game, they don't do any checking of the values going in. And it was a disaster, really, especially when it arrived on PC, where, yeah, you get the idea. And Phantasy Star Universe was then protected by GameGuard, even so. And Phantasy Star Universe was the same. It had a lot of cheaters about a week after the release. So the population went very high at the beginning and then fell down because of all the cheating. And then it stayed online for about 3 years in America, but was shut down. And only Japanese servers are left today. And that's what I reverse engineered. So the first thing you want to do isn't actually this. It's looking at the client executable. But that's not the part I worked on, and that's not Erlang, so I'm skipping this step. So what I did first was logging packets for the game. It was actually in a quite urgent time, because when I did this, it was about 1 month before the game was shut down. So we had to find quick solutions, and I did, maybe not the best, but something that worked. So you can snoop the network. Here it doesn't really work because the protocol is in SSL. You can hook a function inside the executable. This is probably the best, but I had no Windows knowledge, so I couldn't do this. And so I did man in the middle. Actually, I didn't do it myself. Someone found the client certificate, and I simply used it to first try connecting to the server. It worked. And then made the client connect to a proxy on my machine, and then that proxy connect to the server, and decoding and encoding SSL in between, and it worked. I assume there's a way to make sure you can't do that with SSL, but here it wasn't a problem. So at this point we have readable packets, and that's when the stuff starts going interesting. So the next step is simply saving these packets. We take the proxy and add a function to save them to a file. It's pretty standard. Then, this is actually quite dangerous for game developers, because once you have that, you can send any packet. You can filter packets, for example. I could not send packets telling the server that my character was hit, so I was invincible. And that sucks for the game. Yeah. I didn't do it because I wasn't interested in that, but it's always possible. And you need very complex anti-cheat technology on the server to prevent that. Because once you get to the protocol, you can't protect anything in the client. It's filtered. And so you can also send any packet at any time. For example, I could send to the server that I picked object, added it in my inventory. That's also bad. I could become rich in 5 seconds. So, of course, you need to know the protocol to do this. And to do this, we need to analyze it. And first, we figure out the framing, that is packet boundaries, which is here pretty simple. We have a size at the beginning of the packet, and that's it. It's not a problem. So to do this, we need a hex editor. And yeah, no point staying on this. So then when you have this packet boundary, you can start, you do this by, well, you don't want to pass them directly. You want to know what the values in them represent. And to do this, a spreadsheet is the most convenient tool, because you can pass your log files and save for each type of command the server sends, make a different CSV file, and then open it in a spreadsheet, use aggregate functions, and simply deduce what you have here. So that's where actually we found that we had these data types in the protocol, nothing else. So it's quite easy. I didn't put it here, but we also found that everything is little endian. So yeah, I explained this. And when you know the game, you played it, you know what a few values looks like. For example, the player level. And this one in this game goes from 1 to 200. And so, since we aggregated the data, it was easy to find which one was which. But it's not true for all the values. And the hard part is figuring out how the server works without looking at it. And that's when you need to figure out what a few of the values in the packets are, because they tell you exactly how the server is engineered behind. And here we don't have many actually. We have player ID, which was actually displayed in game, so we could easily identify it. We had the area IDs. These are a bit weird because they don't do maps like most other games do. But we have 4 IDs identifying the map you are in and where you spawn. And then the hardest one that took maybe a year to figure out is the target ID. It identifies your player not in the map, but in the zone. So here we have a system that has quests that are broken down into zones, which are simply a collection of maps. And the game, for most things, don't use the map ID. They make everything by zone. So when your player enters a zone, all the players in the zone receive your ID, not even just the players in your map. So even if they don't see you, they receive the info. And also, for example, if you, it was a bit weird to see this, but if you shop at an NPC, we actually had the info sent to everyone in the zone, even if there wasn't a shop NPC. So it was a bit confusing, but once you deduce that they do everything by zone, it works out. They do this simply to overcome client limitations, where you can have quests with many of the same maps with different objects, and it doesn't work if you simply have used the map ID. But yeah, it was a bit weird. So Another thing is looking at the files, because most games now have scripts or identify the objects in the areas, and you can't make a server without knowing this format. Because today games become too complicated. And so the server pretty much runs everything now. How to do this? We simply extract the fields found in the protocol. There's a few of them, mostly requests and zones. And the problem is that you don't know what they represent. You need to look at packets long before telling you this player jumps this map to identify the file. It's quite challenging actually, and it takes a lot of time to parse everything. So, of course, you can get a good SSD. It works. It improves a lot the reading and writing speed. But you can also use parallelisation from Erlang to do it efficiently. And then you need to analyze the files. So it's a bit of a similar problem as the protocol, except you can also use client files. We have a few already with executable, and they share field formats, but not everything. And we actually have the chance to have an offline mode, which is pretty much the same as the online one, except it doesn't connect. And sometimes other games have used the same format. Here, not so much. So to figure out first how the files are archived, we need to remove the game board. That's actually very easy also. You just need a debugger, stop at the right step, copy the executable from memory, save it on the file, fix a few things, and it works. And then you can load that executable, use your debugger, and break at a very strategic point. It is just before loading the new file. So here we have a loading screen and then a login screen. We just make breakpoints at every steps that load the file and wait for the next file load. And then you have the AESM. You just need to translate it. So, yeah, most of the files here were in a very, very weird format. They were encrypted, compressed, and there was other things that I will talk later. First of which, they took the source, changed a very small thing, and put it back. And so you had to look at the executable. And then the algorithm to compress was completely home-built. So same problem here, we had to look at the ASM. And we did it. So this part is the hard part that doesn't use Erlang at all. We can't. It's really a debugger thing. But then, once we have this, we can use Erlang to concurrently extract all the files. And there's a lot of them. I have maybe 10,000 files that I extract automatically with all my CPUs. And even then it takes a lot of time, but not that much. It's about 10 minutes. 10 minutes with what I will do a bit later in the talk. But, of course, you want to extract everything like this because your code may have mistakes, and that's the only way you have to test that what you are doing is right, and to verify that the formats you deduced are proper, because you will have to re-archive the files after modifying them and you need to test those. So then we continue with the files inside the archives, and it's a bit of the same method, except these files are actually pretty much just structs from memory put into a file with a few pointers modified. It's very weird. And then when they load the archive, they load everything in memory, change the pointers, and use them directly. So I think they did this to improve load times, but it's not that good because it wasn't instantaneous. And we need, again, a debugger. But then, when we have enough information to parse all the files, we parse them all. And again, Erlang helps. And that's what, for 10,000 files, 10,000 archives containing about 5 to 10 files, it takes about 10 minutes on my machine. So I think it's pretty good, it's acceptable. Every time I do a change, I can check that the change is right, and that's pretty powerful. And of course, you can also confirm your assumptions by using pattern matching to check that your values are in the right range and type. That's also important because sometimes you think you have found all the different options a setting can take, and then you find the new one and it crashes. So this way you always know the most you can about the game, because you can't really find it elsewhere. Yeah. And the next step is the most interesting. After all this hard work, it was really rewarding to get to this step, building the actual game server. Of course, we need to know if the protocol we looked at earlier is right, except either talking to the actual server, which is done today, except the Japanese one, but this one advanced a lot, it has many changes. And the other way is to make the client work on your server. And that's probably the best, because you can then make people contribute by trying the game for you. And this is how it looks like for this game. We have a patch server that sends the patch files, pretty standard. It's actually quite small, that's the first thing I did fully. And then you have login and game servers. These ones use SSL for connection, and login is pretty much the same as how game starts, but it redirects to another server. So it's mostly an architecture thing on their own. But we are forced to do both. So in the end, for this project, I have actually I support both US and Japanese versions. So I have 2 patch servers, 3 logins, and 1 game server. And that's actually how Cowboy came to life, because I wanted all this plus HTTP for the website on a single release, and that's what drove the acceptor code. But yeah, so we start. We do something very dumb. We just send the packet from one of the log we have, and we'll reach in-game like this. That's about it. Then we try to find out in which order packets are sent. Because if we just send everything, then the game actually replies a few things with your them. And they are important. The game tells us, for example, the login and password used. and we run them for the final game. So we need to figure out the order. And it's pretty much looking at logs, checking against the game that it doesn't loop indefinitely when we wait for a reply. And that's it. So this is mostly trial and error. There's no other way to do it. We don't know anything about the architecture. There's no documentation. I tried asking, of course. No, they didn't want to. So every time we try to make sure we understood a packet or value, we need to test it in-game. It's very, very tedious. But there's a method to get started that make it easier to work with. So when we get in-game, it's actually very easy because you can just open the menus, try a few things, try typing some text, move your character, and the game sends a lot of packets for this. And you figure out a lot of the protocol at once. But what you don't know is what you will have to reply to make sure the game receives what it asks for. And of course, we have the logs and we can find more or less what we need to reply. And then it's just testing again. So we just send a logget packet without modification or minimal modification, for example, the player ID. And then we change values, we see what changes, and so on. And then we write the function, the proper function, to do it in the real server we will use. And then we can also, well, it doesn't always work, but for some commands the server can send, we can just simply use the shell. And it doesn't work most of the time because the game ignores what you are sending if it's wrong. But you can, for example, I will show it in a bit, make your character change area or position in the map. That's quite fun, and it helps figuring out a few packets because you don't have to use the client, you can just send commands, change the values, and so on. So it helps making sure you understand the protocol. And warping, changing areas is very good because sometimes when you open a menu, the game will wait indefinitely. Actually, it's timeout, I think, but it will wait for the server to reply. So initially, you will always get stuck in one or another menu. And it's very, very frustrating. For example, at the very early stage, we had players trying to change areas, and they would get stuck in the stairs, and the character just kept running. It was very funny, but not so much playable. So the client sometimes waits for the server. And to make sure we are progressing fast enough to complete the server eventually, we need a very small, very quick feedback loop. Because if the client gets disconnected or crashes, it also happens, we need to open it again, log back in. It takes 1 minute for this, and then you need to get back to what you were testing. It can take a lot of time, especially if you were playing, fighting enemies or whatever. So we need a process. This process uses code reloading. Mostly, we can, of course, use this Erlang feature to test our code directly, but that's not all. We need also to, we can reload the client, like I said, and we need to not crash the game. We need to have the socket always alive. And that's actually not that easy. It's actually the project I used to learn Erlang. And crashing and process handling wasn't that well understood by myself at the time. What we want to do is simply make sure no error crashes the connection, and print out any info, any error, as soon as the game does something we want to know about it. And it's actually a lot of information, but we can dumb it down a little. And of course, once the game server will have been finished, we can remove that protection and just crash the game once something goes wrong, because it's probably a player trying to cheat. And of course, it's still trial and error, but improved. So I will show you a little demo. Okay. Wait. So, okay. This is the server running. There's not so much. It's Proprietary application now. Okay. So let's start the game. So, okay, this is the launcher. We start the client. Okay, so this is the title screen. Let's log in. Okay, so right now I don't have accounts, but I accept everyone and give a random account. And this is what happens when you do this. You have the client saying, first contacting the batch server, and then contacting the login server with information about the client, say sending info. We authenticate and send this message. Let's go on. Okay. Next, okay, next it asks for the game server, and then we reconnect. It reconnects to it, sends more info, and asks for the character. So I already have one. It's a very standard character, and we can log into the game. So here, what you already see is packets that aren't handled yet. So I just print the name of the packet. This is actually base 10, would be better in hex. And this actually happens a lot when you move, for example. Okay. So this is everything that is broadcast to other clients when you do something. There's a few of them. Right now, I do handle them, but not properly. I don't parse them. I just replace a few values and send the packet back. It works. But it's not the best, of course. And what I was saying earlier is that, yeah, you can try, for example, no, this one works. This one shouldn't. Okay. So this is what happens when you do, okay, this packet is parsed, but there's no function to handle it. So this is good because we know the packet is parsed correctly, and we just need to write the logic behind it. And we don't have, we didn't yet, so we just crash, but don't disconnect. That's very, very important because, for example, there's one I actually prepared a fix for. You can't talk. Okay? So, yeah, there's a crash here because I've modified this not too long ago and didn't undo it. So let's let's fix it. I'm sure you all know all this, but it's nice to see it in a game. Where is it? That is probably here. So this one is a very old file. I'm not too happy with the code, but let's show. So this is the old code, and this is the new code here. Okay, so we just change it, we recompile. Okay, and it's reloaded. So this is actually MochiWeb's reloader module. And what's good is that we can now talk. And that's also true for everything we display here. That's interesting because sometimes I will look at this packet and there's one value I don't figure out. And I can simply add higher format and try again directly. And this is very, very interesting because you always have the answer you search for as soon as you ask for them. Okay, so that was it. Do you have any question?
Any question? Well, I have one question.
Yeah.
So how much state is kept on the server? I mean, and how well can you scale it?
Pretty much almost everything. The things that the client does is the enemy movements, which are synchronized by the server, but does client side, so AI, and so on. But everything else goes through the server. It's entirely server side. Actually, there's 300 commands the client that server can use. It's a very, very complicated protocol because the server does most of it.
So how does it scale? Is it sharded by area? Or?
Yeah, like I said, you have quests, which don't shatter, but you have zones, and yeah, I will. Yes, no, actually, so this one here. It is a map. Yeah. Yeah. So this is because white doesn't do something. So I change map, and you. No, this one is. You can see here. I receive first an event telling me that I need to change the map, and I change it. But this actually, this value represents the quest. This is here. It's a lobby, so you don't have to kill any enemies. There's no goals. It stays up all the time. But this is what represents missions, which are instanced areas where you fight enemies and do whatever. So this represents this value. So this one, 0, is the zone. Like I said earlier, this is what actually divides players into areas. And then the tree here is the map. And the one is the entry point. So, oh yeah, I forgot to show something. So this is the sun map. This is map 2. Okay, and so on. So, what is interesting also when debugging is that if you get stuck, I don't think I have anything to get stuck anymore, but you can always walk the character. So I do this by taking his ID, which is 1, 0, 0, 0, so 1. Okay, giving the request I want, the zone I want, 0, the map, and the entry point. And we get here. And we're just on the floor above the first one we were in. Okay. So this is very interesting because for two reasons. For getting unstuck when you do something wrong, and also to reload the map files. But then to answer your question, we also have this. This is what they call a universe. This is pretty much an instance of the whole game, and we can switch to one or another as we want. It's not like worlds in other games where you choose your world and you are stuck with it. Here, everyone from all over the world can use the same servers. They did 2 worlds actually, but in theory, it's very possible. And if you change, I'm not sure if it will work. Yes. Oh, cool. So if you change your, this one here, universe to Bacon. So the project is actually called EGS eggs, and we have funny universe names. Yeah. And yeah, that's how they cut players into different servers. So this and zones are how they shatter the population. Thank you. Question?
When you finish the server implementation, how will other people connect to your?
They just download the normal game. Well, no, they should buy it. Yeah, you just have to get the patch executable, and this one has all the correct IPs in it, and it just connects. And then the patch server sends everything else you need, and it works.
And you use your Cowboy?
Yeah.
Presumably when you finish this, you're going to keep maintaining Cowboy?
Oh yeah. Cowboy is my business. So, yeah. I'm not sure I will finish this. I hope, but it takes a lot of time.
Any other question? So thank you, Loïc. Please give another